ahead and get started. And today we'll deal with the dreaded loops. All right. So have you guys read the notes? At least the parts that we have talked about so far. We don't need that, right? No, you do. Trust me, you do. So let me point out where we are in terms of the notes, and then we'll go from there. Double check on the recorder. Make sure it is recording. It is recording. Okay. All right. So where we are right now is here, 3.6. We have covered 3.1 all the way up through 3.5 at this point. And we are down to 3.6, which is the most difficult part of the entire thing. Because when you have loops, the precondition of something will involve the post-condition of exactly the same thing. So for this discussion, I think I'm going to use the whiteboard a little bit. And just a little bit. You can copy just that part onto your notebook. Because I think the graphical representation will help a lot in terms of understanding how loops behave and how do we figure out the pre and post conditions of everything. Whenever possible, I will use the computer so that everything will be captured in the screen recording. But if it is not possible, I will still have to draw something on the whiteboard. It's just not a whole lot, but it is there. Okay, so let me start with writing the pseudocode in a text editor first and put it onto the projector, and then I'll draw pictures next to it. We'll go ahead and just use a plain text editor here for the program. And we'll start with something that's relatively simple. So we'll say while x is less than some value k, do the following. X gets x plus 1, 3, and while. That's my entire program. Can we trace this? Can I trace it without knowing anything about x or k? Not really. So, but let's see if we can analyze this program using the pre and post conditions. And then we'll also start to see how loops really make pre and post conditions difficult, unlike conditional statements. Conditional statements we can deal with, but loops is a little bit harder than that. Okay. So I'm going to keep this one on the screen so that we can refer to it whenever we need to. I'm still thinking whether I want to draw the picture using a drawing program or whether I should do it on the whiteboard. I'm thinking. Drawing program, let's give it a try. This would be a good excuse to get a tablet. This is a software called Inkscape. It's a hand drawing program. So whatever I do here, I can actually save it and upload it onto Moodle, and that's why I want to do it this way instead of using the other way. So I would use this tool here. Maybe this tool is a pencil, and draw the basic shape of a loop. A while loop or pre-checking loop, kind of looks like this. The way I usually draw that is it has a way to come back from the body of the loop. And then after that, we can branch. One branch just goes all the way out of the loop. And the other branch goes into a statement of some kind. And here's the branch. It separates the two paths. Like that. And then we'll continue to draw the operation inside. After the operation, it has to go back to the beginning of the loop. So it just kind of loops around here. And I'll draw this path and finish the picture. I think it's good enough. What do you guys think? It's crude, but it gets the job done. Good enough? Okay. Probably not good enough for a biology class, but for an algorithm class, it's mighty good. All right. So what we want to do is to put the statements around here, And I can just use text to put up the question here. Our condition is x is less than k. And then over here we have an operation of x gets x plus 1. And it doesn't fit because I picked a font that's too big. Let's pick something smaller like that. Now it fits. Okay. Are we still doing okay with this picture? All right. So now I want to identify what is my precondition, what is my post-condition, and so on and so forth like that. All right, the first thing we want to do is to state what is pre-1. I just did something that I did not want to do. Nope, redo. Okay. So what if I just tell you that I don't know anything before line 1 executes? In other words, I know absolutely nothing about x or k or how they relate even. Okay, so it is possible that x equals k to begin with. It is possible that x is less than k to begin with. It is also possible that x is greater than k to begin with. I just don't know. Okay, I just want to make this as general as possible. Any questions about that assumption? In this picture here, where would I indicate to be my pre-1? Right about here, before we get into the entire thing, in the loop here. So I'll just go ahead and draw, this thing here, and then we'll call this pre-1. So we'll use a smaller font and say this is our pre-1. And we might want to change this from a solid shape to a hollow one, so we can change the fill, change the stroke. There we go. All right. Are we doing okay with pre-1? Does it make sense? The pre-1 is over there. I'll just do all the easy ones first. Let's deal with post 3. Duplicating this shape here. Post 3 would be about here when I'm done with the entire loop. Is that about right? Because when we talk about post 3, it is after and while, which means we are done with the loop. We have exited from the loop here. So we'll go ahead and put a little annotation here and say this is post 3. That's easy. Pre-1, post 3, easy to identify because 1 is the incoming part of the entire algorithm and 1 is the exiting part of the entire algorithm. Now we have to think about pre-2. Okay, pre-2 gets a little bit complicated, so we'll skip it. We'll talk about post 3 first. Where should I put post? Excuse me. Where should I put post 2 in this case? The condition of line 2. I have a lot of places to choose, don't I? Because I can put it right here. I can put it right here. I can put it even right here. They are all basically post 2 because those are all representing the conditions of what happens after line 2 executes. That's easy. So I'll just pick a convenient place by duplicating this symbol. No, that's not what I want. Just want to duplicate and move it. We'll put it here so that we have some more space for other stuff later on. Let's put it here. And we'll annotate it as our post 2. Are we still doing fine with identifying which pre or post condition is where in the picture? Still makes sense, right? Now we have a problem. The big problem has to do with pre-2. Now we know where to put the pre-2, don't we? Because pre-2 is right before line 2 executes. So it'll be right after the branch, but before the operation starts. So we'll go ahead and do the same thing here by duplicating this symbol and drag it over here. And then we'll annotate this as our pre-2. Hey, that doesn't seem too bad. I mean, this is pretty easy stuff. The big question is, how do they relate to each other? That is the biggest question. All right. Why do you think this is difficult? Well, first of all, do we have any merge points in this picture? Is there any place, any junction, where two paths can merge into one? Right here, right? This is a merge point, because I can get to this point here by coming in the first time, or I can come back to here after an iteration. In fact, I can come back to here after any number of iteration. So that's a merge point. This particular merge point presents a particular problem, because now, if I want to express what is pre-2, what do I have to say here? Because now I have two ways to get back to this point. What is the first way to get to pre-2? The first way to get to pre-2 is from the first iteration, which means pre-1 has to be true at that point. What is the other way to get back to pre-2? After one iteration, so post-2 has to be true. Now, since when I'm standing here, I do not remember which way I took to get back here, we have to use a disjunction to say that, well, it can be either way. It has to be at least one. Okay, I have to rephrase that. It has to be at least one. But either case, I also have to know one thing has to be true before I am about to execute line 2. What has to be true in this case? No. X is less than k has to be true, because otherwise I would not be making the choice to go here. I would be making the choice to go the other way. So I know for sure that x is less than k has to be true, and I know at least one of these two, pre-1 or post-2, also has to be true. Okay, well, that's pre-2. I'll just kind of leave. Well, we'll simplify here because we have a simple way to simplify. In this case, what is this part going to simplify to? Let me just highlight the part. What is this going to simplify to? What is pre-1?
True.
Pre-1 is true, which means I don't know anything about any variable. What is true or anything? True, exactly. True or anything is just true. So we now have true and x is less than k. And how do we simplify this? True and something. It becomes just something. Okay, so let me just kind of sidetrack a little bit and show you why true or something is always true. Okay. It's easy. This one is really easy to prove because we only have one single variable, which is x. As a Boolean variable, x can be true, x can be false. When x is true, true or true is true, and therefore it is true. True is always true. When x is false, what is true or false?
True.
It's true too, and then the other expression is also true. So that shows that true or whatever is always just true. It is simplified. Okay. All right, then that's how we can do this simplification from this step to a single true. That's because of this truth table here. All right, well, that's pre-2. And after pre-2, we have to deal with x gets x plus 1. So how do we determine what is post-2 in this case? Remember those questions that we had to ask in the previous class? Now, whether it is inside the loop or not, an assignment statement is an assignment statement. So we still have to ask the same questions as what we did last time on Tuesday. Does anyone remember on Tuesday what kind of question we were asking? Let f of x be the right-hand side of line 2, right? So the question is, does f have an inverse? What do you think? F of x is x plus 1. Is there any way to counter the action of adding 1? Subtracting 1, right? So then we can say f prime of x is just x minus 1. To counteract adding 1, we just have to subtract 1. So an inverse does exist. If an inverse exists, should we use the forget rule or should we use the substitution rule? Use the substitution rule. So that means post2 is using the substitution rule on pre2. We locate all the mentioning of the variable on the left-hand side of the assignment. In this case, it's x. And replace each instance with f prime, the inverse function applied to x. And then we can do the actual, we can substitute the actual value of pre2 into here, which is x is less than k. And f prime is just x minus 1. And now we can do the actual substitution, which means x minus 1 is less than k. Are we still doing okay so far? Okay, we're reusing some of the stuff that we learned on Tuesday. Now here comes one step that we can only apply when x is an integer. If we know that x is an integer, we can say this too. Is everyone convinced that if x is an integer, which means it can only be whole numbers, positive, negative, or 0 itself, when we say x minus 1 is less than k, it really is saying the same thing as x is less than or equal to k. Okay? Now, it doesn't work if I don't tell you ahead of time that x is an integer, we cannot do it like this. But since I tell you that x is an integer, now we can do this step here. Now this is a very important step because it makes everything else a lot simpler. All right, so we have post2 now. What is post3 now that we know what is post2? What are the two ways to get to post3? The first way is pre1, but somehow pre1 fails, x is less than k, and then that will get us all the way out like this. Okay. So if it is the first way out of this loop here, what has to be true other than pre1? So pre1 has to be true, but on top of that, something else also has to be true. X is greater than or equal to k. But there's another way to get out of this loop is after one iteration. After one iteration, we know that post2 has to be true. Are we doing okay so far? Inside the disjunction or the or, the first one is basically saying, what if we cannot even go through one iteration and decide that it's time to get out of the loop? The second component of the disjunction says we have to go through at least one iteration and then we get out of the loop, and therefore post2 has to be true in that case. But regardless of whether we go through 0 iteration or any other number of iterations, one condition has to be true when we're exiting a pre-checking loop. The condition has to be false. X is less than k has to be false, and I just do a simplification here. X is less than k is false. It's really the same thing as saying x is greater than or equal to k. Are we still doing okay? And how do we combine these two? Pre1 is just true. Post2 is, well, I can just substitute it here, but it really doesn't matter. Right? And we already know how to simplify this one. It becomes true. And then the other one is like that. And then this simplifies to just x is greater than or equal to k. In other words, when we get out of a pre-checking loop like this, the only thing you can guarantee is that x is greater than or equal to k. Are we doing okay so far with this particular example? But this is not very typical. A lot of times when you have a loop that looks like this, we have some sort of initialization to make sure that x is less than k to begin with. In other words, pre1 usually says x is less than k, or it has a particular constant that has to be less than k. So let's see how that will change this entire picture. So we'll go ahead and just restate it here and say, let's say we know more about pre1. So let's say in pre-1, we say x is less than k to begin with. Okay? And that really changes a lot of things because the simplification that we did here doesn't work anymore. Okay? Now when that doesn't work, bad things will happen. Well, I wouldn't say bad things, but more complicated things will happen. So let's see how that would impact this entire thing. When pre-1 is, yeah, we know something about x and k. X is less than k to begin with. Okay, that's what we are changing now. We're changing the assumption of pre-1. But that's going to have a lot of downstream consequences because pre-2 is still about the same thing because it is still pre-1 or post-2, and x is less than k. That has not changed. Because this part here, let me highlight which part I'm talking about, because this part has to do with the structure of the code. It has nothing to do with the actual pre and post conditions. Are we doing okay so far? Does everybody understand what I just said? Pre-2, the way I have highlighted it at this point, has to do with the structure of a pre-checking loop, has nothing to do with the actual pre-1 in this case. But now that we know pre-1 is x is less than k, I can no longer do the simplification that I was able to do earlier because post-2, I cannot get rid of post-2 in this case. Before, I was able to, yes, go ahead. Absolutely. Is the font size okay?
Yeah, font size is good.
All right. Is that good?
Yeah.
Okay. In the good old days with a real projector, then I would just have to change the mirror. We still have that. Behind the projector is an actual overhead projector. All right. Now, before I was able to do the simplification, because before, when pre-1 is true or whatever is always true, and that's how we can simplify this disjunction into just true, and that was advantageous. It's easy. But this time, I cannot do that anymore because pre-1 is not true. Pre-1 is x is less than k. I can no longer use that simplification technique. Attack. We have something else that we can do here. Can't we use the distributive law of some, to make this a little bit different? Seems like we can do something about it. And the answer is yes, we can do a little bit of simplification using the distributive law, but it's not a whole lot. Okay. Let's see what happens when we use the distribute the disjunction over the conjunction. Now when we do that, we have x is less than k and x is less than k. Group them into one. And then we have or. The other part is post-2 and x is less than k. And what do we end up with? The same thing, right? Because x is less than k and x is less than k, can we simplify this a little bit? What is that? That really is just one single x is less than k, right? I mean, repetition is not going to buy me anything. And then on the other side, what do we have? The same thing as last time. Those two, and x is less than k. So we still cannot get rid of post-2 here. Or can we? All right, let's think about it this way. This is the same as this here. Okay, we already know that. That's no big secret. The conjunction is going to make this entire thing more restrictive, right? So fewer things will fit this requirement than fitting this requirement. But now we have a disjunction here. which means it is if this is strictly more restrictive than this, the disjunction says it's really the same thing as just that. Yep, go ahead.
I want to know because the first term isn't true, then the second term never will be true.
Say again?
If the first term, x is less than k, isn't true, then the second term cannot be true.
Correct. But what about if x is less than k is false? Oh, you just said that. But what if it is true?
Because it's an or statement, it doesn't matter.
Exactly. So that means we just need to retain the first term. So in this case, this whole thing just boils down to x is less than k. Is everybody convinced that we can just boil down the entire thing to x is less than k? Okay. Now, if that is the case, aren't we back to where we had it before? We had x is less than k before, and now we have x is less than k again. So we're good to go. But we can't really do, we have another problem here. What about this thing here, which is also going to refer to post 2? And last time we were able to simplify it just like this, and this time we can't do the same simplification. In other words, post 2, this part here we can just copy and paste because pre 2 is the same as last time. The post 2 derivation would be the same as well. But we cannot do the same thing with post 3. Now, last time, this part we can still copy and paste because once again, this part is dictated by the structure of the code. Okay, it has to do with the shape of the paths and how they merge. So this part is still the same. But we can't do the simplification as last time. We can do some simplification, but not the same way as last time. Pre-1 this time is x is less than k. Post 2 is what? X is less than or equal to k. And the whole thing, on the outside is x is greater than or equal to k. And I think it is time that we can just pull this over a little bit. And last time we were able to do some simplification because pre-1 was just true or anything is true, and that's how we can do one single simplification and be done with it. But this time we can't do it. But we can do a different type of simplification. And we'll go ahead and take a look at what. There's a way to simplify this. First of all, do you think one expression or one comparison covers everything that the other one covers? Does one imply the other? I don't care which one at this point. Does one imply another one, the other one? Okay, which one implies which other one? The first implies the second, or I should say the left implies the right. X is less than k implies x is less than or equal to k. But I cannot pick x is less than k in this case because or is going to take the one that is more general. So we have to pick x is less than or equal to k in this case. We'll talk about implies, implied by, and equivalent in just a moment. But in this case, because x is less than or equal to k is implied by x is less than k, and this is a disjunction, we have to take the more general expression, and this is what we have. Can we simplify this a little bit? X is less than or equal to k, and x is greater than or equal to k. Can we simplify it? They're the same. Exactly. Exactly. So we can say x equals k. Is this post 3 different from the other post 3 earlier? If we know that x is less than k to begin with, then we can actually say that by the time the loop finishes, x equals k, not just greater than or equal to k. Yep.
Since you stop when x equals k, you can't move forward. This has been proven true. You can't make x be greater than k with this loop because you have to stop when it's equal. So that's why it's proven that way, because that's how it works.
Yes.
So if pre-1 was x equals k or x is greater than k, then the only way x could be greater than k is if x was greater than k in the very beginning. Which is why the first one with true is why it was x is greater than or equal to k.
Correct. Yes. It follows the same rationale, except in this case it is all spelled out using mathematical proof. So you have the same gut feeling. You know that the result makes sense, but this way going through the derivation, we can actually prove it step by step, and there's no quote unquote obvious in this case. Every single step is there's a rigid reasoning from one step to the next. Okay. Are there any questions about loops? No questions about loops? Now there is a special name, post2 actually has a special name. Post2 is also called, yes?
So the end result of loops is that they're both going to have the same result in the end, right?
Could you repeat that?
So the result of loops is that in the end it's going to be the same end result, like from the beginning to the end. It's going to.
In this particular case, if we know that x is less than k to begin with, and x is an integer, we are guaranteed that by the time we get out of the loop, x equals k.
Okay.
But post2 in this case also has a special name. It's called a loop invariant. It's called a loop invariant because post2 is always true. It's true when it's inside the loop. It's also true by the time we get out of the loop. And that's why it's called a loop invariant, because it does not change. It's a condition that has to be constant, always true, whether we are going in, when we're still in iterations, or by the time we get out of the loop, post2 still has to be true. All right. But loops are not easy to figure out because of the merge. Yep.
In post2, when we have the third line, x minus 1 is less than k, why is it automatically becomes less than or equal to k?
Because I said that we make an assumption that x is an integer. If x is an integer, okay, let me just add one more step. That should make it more complete. Can anyone see how this is really the same as that?
It's still going to be greater than x?
Correct, but if x is an integer, that means if x is less than k plus 1, ax is also less than or equal to just k. Because I can only change the value of x 1 by 1, so there's no in between, and therefore it has, if this is true, that has to be true as well, and vice versa.
Okay.
Okay. Are there any questions at this point about the loops? No questions? And that's why loops are a little bit more complicated because of the merge, and also because it comes back to the beginning. All right, so this is a good time where we can spend a little bit of time to talk about implies, implied by, and equivalent to. In English, it's very confusing because we are talking about the differences between if, only if, and only if, and computer science people don't like to type all that stuff. And I think if and only if is IFF, that's a short form of if and only if. Are they really the same thing? Or if they're not the same thing, how are they different? And why do we care about these things? That's the next question. So I'll give you a statement, and you guys can tell me, when you can get your refund. Okay. So TAC is going to make a bunch of statements. If my statement is true, okay, let me roll back a little bit here. You pay me $50 for my statement. If my statement is true, you cannot get your refund. But if you can prove me wrong and say, TAC, what you said is not true, I can refund your $50. Okay? So now you have some money into the game and more incentive to pay attention now. All right, so we'll this is text statement. Okay, so text make 3 statements in this case, and you have to tell me when you can get your refund. So text statement 1. Okay, if the sky is red, then the earth will shake. Okay. I just want to make sure that it is politically and religiously correct all the time. So that's why I have to think. No references to any type of religious, writing or books or whatever. Okay, so this is my statement. If the sky is red, then the earth will shake. Okay, there will be earthquake. There are 4 possible cases to consider. The 4 possible cases to consider is, well, the sky is red is a Boolean statement. It's either true or false, right? So once again, we have this can be true, and the earth shaking is a statement. It is either true or false. It is observable, and you can say whether it's true or false. The sky is true. The sky is red, but the earth is not shaking. And then we have the sky not being red, but we have an earthquake. And then we have the sky not being red, and there's no earthquake. So those 4 are the possible outcomes of the combination of these 2 conditions. Are we doing okay so far? The sky being red is considered a condition. It's either true or false. The earth shaking or having an earthquake is also a condition. It's either true or false. Are we doing okay so far? So the question is, when do you get, okay, tag keeps your money. Okay. So the question is, when do I get to keep your money? Because when the statement is true, I keep your money. When the statement is proven false, you can get your refund. In the first case, can I keep your money?
Yes.
I told you if the sky is red, the earth will shake. And you go outside, you look at the sky, yep, that's pretty red. And and then you see buildings crumbling around you because the earth is shaking. Well, of course, at that point you would not be that concerned about your $50, but can I keep your $50?
Yes.
Yes, I can take it to my grave. Yes, very good. So that means the statement itself is true. The next statement is the sky is red. You look out, the sky is red, but there's no earthquake. So now, so what do you think? Can I keep your money? No, because what I said is incorrect. It is not true. Okay, so it is false here. The statement, this entire statement, is false, and so you get your refund. And in this case, you can slowly and calmly come to me to collect your money because there's no earthquake. What if the sky is not red, just like today, gray, blue with puffy clouds and stuff, but there is an earthquake?
So false.
Can you come to me and ask me for a refund?
No.
The answer is no, you cannot. I get to keep your money. Okay? And the last one is the sky is blue and the earth is not shaking. Obviously, you cannot get your money. All right. So what are we really talking about here? Now, when we use the English words if, then, it's kind of ambiguous. Okay, we think we know what it means in logic, but we really do not know exactly what it means in logic. Let me change it to another form, and then you will see more, precisely what this means. This is really the same thing as saying the sky is red. Okay, let me put in quotes here. The sky is red implies the earth will shake. That's what if is doing. When I say if the sky is red, then the earth will shake, I'm really saying the sky is red implies the earth will shake. I'm not suggesting any causal relationship. I'm simply saying when one is true, the other one has to be true. That's all I'm saying. There's one other way to say this. The other way to say this is the sky is red is a sufficient condition of the earth will shake. that, I think, is probably the best way of looking at this, because if something is a sufficient condition of something else, it means nothing else matters. If the first condition is true, it is already sufficient to confirm the second condition also has to be true. Are we doing okay so far with this? Well, in logic, when we program, can we do something like this? Can someone give me an example of a particular condition being true is a sufficient condition that something else also has to be true? We have just seen it. X is less than k is a sufficient condition of x is less than or equal to k. A more restrictive condition is sufficient for a more general condition. Because when the more restrictive condition is true, the more general condition also has to be true, but not the other way around. Okay, so now let's go ahead and copy and paste some of this stuff here. So my second statement, you pay another $50, and I give you another statement. And this time, I just added this much. Only if the sky is red, then the earth will shake. And the refund condition is going to change a little bit. Okay, so let's go ahead and start with the first one, the most obvious one. I tell you, only if the sky is red, then the earth will shake. You walk outside, look up, not good, the sky is red, and the earth is shaking. Okay, there's an earthquake. Can you get your money back? Only if the sky is red, then there'll be an earthquake. You look out, you go outside, they're both true. Can you get your money back? You cannot get your money back because what I said was true. Okay? Now, what about the second one? You walk outside, the sky is red, and there's no earthquake.
Get my money. I get my money back.
No, you cannot have your money back. You cannot have your money back in this case, and I'll explain, that in other terms why you cannot have your money back. The word only is really quite powerful because it says, in a nutshell, what it says is the only thing that can cause the earth to shake is the sky being red. But it doesn't say anything about if the sky is red, the earth has to shake. Okay? And we'll talk about this in other terms, and it will be much more obvious why that is the case. Okay, the third one says only if the sky is red, then the earth will shake. But you walk outside, the sky is not red, it's blue just like today, and then there's an earthquake. You get your money back.
Yes.
And then the last one, you cannot get your money back because the sky is blue and everything is calm. You don't get your money back. So how do we say this in terms of imply? In this case, the sky is red is implied by the earth shakes. Okay, because will kind of implies a causal relationship, but there's none here. But if you change the tense a little bit, if you present this to your English teacher will say, but there's no need to use a passive tense here, because you can also say it is exactly the same in this case to say the earth shakes implies the sky is red. It really is the same thing.
Why is the last one true?
Why is the last one true?
Yeah.
Because if the sky is not red and the earth does not shake, then it's not conflicting with my statement. It doesn't conflict with my statement, which means my statement is automatically true.
But your statement says that the sky is red and the earth will shake. And
Right.
the last line says it's completely wrong. It doesn't come.
You mean this
Sky
line here?
And the earth is not shaking, which makes it true.
The sky, yeah, because what I said is only if the sky is red, then the earth will shake. I didn't say anything about what if the sky is not red. It can be anything.
There's
If the
nothing
sky
to
is
prove
not
at
red,
all.
then I can Yeah, exactly. It's nothing to prove me wrong. Exactly. Now the next way to look at this will make it very clear. Okay? Because the next way to look at this is to say the sky is red is a necessary condition of the earth shakes. Okay? Now that I think is the best way to look at it, because it simply means that there may be other things that will contribute to the earth shaking, but the sky being red is a necessary condition. It has to be there. It's a necessary ingredient for the second thing to happen. Are we doing okay so far with this? It's kind of like saying, chicken soup. In chicken soup, chicken is a necessary ingredient. Okay? So you look at a pot of soup and you say, I see other stuff, but I don't see chicken. Is it a chicken soup? No, because chicken is a necessary ingredient. But when you look into a pot of soup, you see chicken, does that automatically make it a chicken soup? No, because if it is a necessary ingredient, it may not be sufficient. So maybe maybe chicken soup also needs noodle, celery, carrot, and the whole 9 yards. Is that okay? Okay? So in comparisons or just usual conditions that we have to deal with in programming, one little way to say this is to say x is less than or equal to k is a necessary condition of x is less than k. In other words, this has to be true in order to make this true. If this is false, okay, the other way to say this, if this is false, there's no way that this can be true. Is that making any sense? All right. So now you pay another $50. Since you don't have to pay anything for textbooks for this class, you have all that money in your pocket. So now my statement is,
That statement is false. Where's my money?
if and only if the sky is red, the earth shakes. Okay, I'm just going to change this. All right. So we have the same four possible outcomes. You walk outside, you observe the sky, you feel the ground, and you see, in this case, in the first row here, you walk outside, the sky is red, and you have an earthquake. Can I keep your money?
Yeah.
Sure. Okay. And you walk outside, the sky is not red, but we have an earthquake. Can you get your money back? When I use if and only if,
Yes.
you get your money back, so I cannot keep your money. And for the third row, you can get your money back too. But the last row
You get to keep the money.
is true. Okay, because my statement is this time is very restrictive. It's saying the sky is red is both sufficient and necessary at the same time.
I know we get the last part.
There's nothing to contradict his.
You got it. I got the last
If
word.
it's blue, the sky's blue, and the earth is shaky, then what Pac is saying is true.
You only get your money back if you can prove it wrong. If there's no ground shaking and the sky is not red, you
Yes.
have no evidence to prove that what he said is false.
Correct. Let me just repeat that so that my microphone would capture that. You're saying that if there's no evidence to prove my statement wrong, then the statement is still considered true. You cannot get the money back because my statement is still true. If I don't say anything about, okay, let's take this to the extreme here. This is my statement. If and only if the sky is red, then the earth shakes. And Obama would win the election. Do you get the money back?
There you go.
Okay? What I said here has nothing to do with the election at all. So you cannot get your money back because you cannot prove me wrong. I didn't say anything about the election. Right? So it's basically that. All right, but let's take a look at, but what if we want to use the other ways of looking at the same thing to say the same thing here? If you want to use implies and stuff like that, the best way to do it is not even to use imply. In this case, we'll say is equivalent to. Now this is a very strong word, is equivalent to, because now it is the same thing. Okay, because if one is true, the other one has to be true. If one is false, the other one has to be false, and it goes in both directions. So that means I only have to tell you one thing and you already know the other one is true or false. If I tell you, oh, today's sky is blue, you already know immediately there's no earthquake. If I tell you, if you're inside a building and you cannot see the sky at all and you feel the earthquake, you can tell right away the sky has to be red. Because it is both ways. Okay, one is sufficient and also necessary for the other one. So if you want to look at it from the necessary and sufficient perspective, this is what it looks like. In this case, it's a necessary and sufficient condition because it goes both ways. What can I do about the example here? Okay, using less than or equal to, that sort of thing. I can say not x is less than k is equivalent to x is greater than or equal to k. In other words, one is truly equivalent, exactly the same as the other one. If one is true, the other one has to be true. If one is false, the other one also has to be false, and it goes in both directions. Are we doing okay so far with this discussion of what implies what else? Now, what does this has anything to do with programming?
How broad do you want your program to be?
Okay. Well, you want to be able to simplify conditions in some cases. Okay. So the implies, can help you with that, especially when you have a disjunction or a conjunction. It can help you decide which side you can simplify and remove out of the entire expression. But it also, gives you one in your mind right now, or in my mind. I have a question. It has to do with the conditional statement itself. Remember what a conditional statement is? Okay, let me give you a conditional statement. We have a conditional statement, let's say something like this. If x is, if x equals 5, okay, then z gets a value of 2, else z gets a value of 15, and if. Something like that simple, okay? There's no particular meaning to this, so we cannot really say it's right or wrong. It's just, behaves in a certain way. But note how we use if and not if and only if. So with our understanding of if from my first statement, this conditional statement really does not have a predictable outcome sometimes. Because when we use the word if, it simply means if this is true, then we have to take this branch. Does it say anything about what happens when this is not true? It doesn't. It really does not. So if this is not true, then we can take this or we can take this according to the meaning of if itself. So that means in programming, if really should have been if and only if. If we want to be picky about it and nitpick, the terms in programming, if as a conditional statement indicator should have been if and only if. Because when we say if and only if, then it means it's very clear. If this condition is true, this has to execute. If this condition is false, that has to execute. It also goes back and say, if I just executed this statement, I know this condition has to be false because it goes both ways. But this is just my nitpicking. You will never hear this ever again from another professor. In fact, if you mention this to any other professor, they will just frown at you. Because the term if as the keyword of a conditional statement is so ingrained and so commonly used that people don't even think about it like this anymore. And this also brings back to the question of what does it take to become a good programmer? Okay, let me rephrase that question. Do you think whoever came up with using the English word if as the keyword of a conditional statement, do you think that person was a mathematician first? No, because if that person were a mathematician first, that person would have picked if and only if, because of the difference of the meaning. But this is really just nitpicking on my part. Again, it's not important. It's just, to re-emphasize the importance of identifying which one is which one. Are there any questions at this point? No questions? So we are pretty much done with pre and post conditions at this point. We can go through a few more examples so that we get a little bit more practice, out of this stuff. So we'll go ahead and, try something, do a few exercises here. We'll go ahead and say if a very simple program. Once again, it doesn't seem to have any particular meaning, so I cannot really tell you whether it is right or wrong, because we cannot say it's right or wrong unless I know exactly what it is supposed to do. But since I'm not telling you what it's supposed to do, we can only talk about the behavior of this code. So we'll do it in both ways. The first thing we'll do is to go forward, and then you can tell me what is the post condition. So going forward first, I can tell you, I have to give you what is pre-1. I can give you something more specific, or I can give you something that is not specific at all and say, I don't know anything about either variable, x or z. I have no idea what the values are at this point. According to the structure of the code, what is pre-2? In other words, I am about to execute line 2. What can I say that has to be true when I'm about to execute line 2? Okay. Well, whatever in pre-1 still has to be true, because I have not had a chance to change anything yet at this point. But also the condition of the conditional statement has to be true because I'm taking the then branch. So that means the condition, which is x is greater than or equal to 20, also has to be true. Pre-1 is already known to be just true, and we also know how we can simplify this because it's a conjunction, and we have the identity of conjunction being true on one side, so it just becomes x is greater than or equal to 20. We can apply the same reasoning to line 4. We have not had a chance to change anything, but the condition has to be false. I'm just going to simplify here, and instead of saying it is not the case that x is greater than or equal to 20, I'm just going to say x is less than 20. Is everybody okay with that simplification? Is that okay? And we can apply the same simplification here because pre-1 is just true, so whatever the second condition is becomes the result of the simplification. Now we have to deal with post 2. But in order to figure out what is post 2, line 2 is an assignment statement, we have to ask those questions again. So in this case, we'll say f of z, which is the right-hand side of line 2, is equals 5. So the question is, do we have an inverse? We don't have an inverse because the right-hand side does not even mention z itself. So we will say fz has no inverse. Use the forget rule. So to use the forget rule, it means post 2 is the result of forgetting something in pre-2. Anything that mentions anything about z, we have to forget because z is the variable being changed on line 2. But after that, after line 2, we can also confirm that z has a specific value, which is the right-hand side. In this case, it's just a constant of 5. When we apply the forget operation, we can expand what is pre-2. We know what pre-2 is. We just figure out what pre-2 is over here. So we have z, x is greater than or equal to 20 is pre-2. Does that mention anything about Z? Nope, has nothing to do with Z, so we have nothing to forget, so we get to keep the entire pre-2. But on top of that, we also know that Z equals 5 at this point. We can apply the same boring reasoning to line 4. So on line 4, we can say, okay, we'll say on line 4, this one is on line 2. On line 4, f of z, or the function on the right-hand side, is just a constant of 7, and f of z has no inverse. And as a result, we will use the forget rule. So it's the same type of transformation, except z gets a different value this time. It gets a value of 7. And then we just expand what is pre-4. Pre-4 is x is less than 20, which doesn't mention anything about z. So that means we have nothing to forget, because we only want to forget anything that mentions z. And now we have post 2 and post 4. Any questions? Yep, go ahead.
So when we have no inverse, we're just using the forget rule?
Mm-hmm. Well, for this class, yes.
Why didn't you forget the z equals 5 and z equals 7?
Because they are not related. We are on 2 different branches here. This is following the then branch. This is following the else branch.
Well, I know, but I'm saying you said something like forget everything with z equals 5.
But z equals 5 is not a part of pre-4. Because when you use the forget operation...
I'm not talking about pre-4. I'm talking about pre-4.
You mean over here?
Yeah.
Because the end z equals 5 is outside of the forget operation. When you apply the forget operation, you're only applying that to pre-2. The end z equals 5 is outside of the forget operation. Yep.
Okay, so we have x is greater or equal to 20.
Mm-hmm.
And then in the pre-4, it turns out to be less than 20. How's that working out?
Applying to two locations.
The top, right there, pre-2 and pre-4.
On the top here?
Yeah, so x is greater or equal to 20.
Yeah.
And then we're doing the pre-1 and x is less than 20. But it's
That's
not
pre-4.
defined
Applying
anywhere.
to
But that's-
the one.
This is what we can say when we take the else branch right before we execute line 4.
The 2 lines, the post, 2 lines, and the 4 line, those more lines, 2 separated.
I don't understand.
Okay. You might want to re-watch the video recording of Tuesday, because we talked about this conditional statement on Tuesday. It's the same reasoning as last time, it's just the derivation is different this time. So you might want to watch that again, because we kind of talked about almost exactly the same thing last time in a slightly different example. It has to do with when you're about to execute line 2, this condition has to be true, because otherwise we would not have taken that branch. When you're about to execute line 4, the condition has to be false, because otherwise we would not have taken the else branch. Yep.
I was going over the videos on the Subcross YouTube channel, and
Mhm.
it was from the audio on
So it's a silent movie.
whatever.
There's one other resource. If I accidentally forgot to turn on the microphone, you can try to go through my screen recording from last semester, because I teach the same material every semester. So you can kind of look up about the same time last semester, and there will be another class recording that explains the same concept. Or the semester before that. I might have at least like a few years of recording online. Why do I even bother to stand here to teach the class? I can just automate it, play a script,
There you go.
bring up YouTube and I just walk out of the classroom,
Postman.
come back and clock the room at the right time. Yep. Sorry.
You wouldn't get questions that way.
Exactly. Exactly. That's the main difference between teaching a class face-to-face and teaching an online class. Okay. Any questions? I mean, because I can explain a specific thing, but I cannot repeat what I said on Tuesday, the entire thing.
On the forget real quick, if you scroll down a little bit, where it says forget pre-2 comma z, why is the z instead of the parentheses there? What's that say?
You mean here?
Yeah.
That's because they're
I understand forget x is greater than or equal to 20, but explain what the z, what's comma z say?
That means, forget anything that mentions z in here. This is our precondition. This is where we start. But I know certain things cannot be true anymore because we are changing the value of z.
Okay.
And that's why we have to forget all the components that mentions anything about
So
z.
in this program, z didn't have a previous value, but now.
Right, pre-2 has nothing to do with z at all.
Okay.
So that's why I got nothing to forget because there's nothing that I stated about z before line 2 in this case.
But most of the time, z will probably have a value previous, and you need to forget it.
If I did have anything to say about z before line 2, then I might have to forget it. In this class, we'll go ahead and forget everything that we knew about z and then restate, z equals 5.
So he made the first statement false to get to the line 4. And so this x less than 20 turns this statement 1 into false. So he went to the line 4 and did the further operations, right?
Well, something like that. I cannot, just re-explain it the whole thing, but I think you get the general idea. One of the best thing you can do is to look at it from the picture perspective, because you remember that you can only take one of the 2 branches. Yep.
I think what is kind of confusing him is the fact that you have the 2 different ways to go into one trace, I think it's called it. Instead of
It's
having
not a trace.
pre and post to
Oh, okay.
separate.
You mean? Oh, all right. I see.
Pre and post for separate.
So it would be better if I did this.
I guess, yeah.
So we basically stay on line 2 all the way from here to here, and then we stay on line 4. Oh, where's the other one? Where's
That
pre-4?
looks better.
There you go.
I got rid of pre-4. Sorry?
Rewind that.
Oh. There we go. So is that better?
Mm-hmm.
I do it. I do pre-2 and pre-4 because I can apply the same reasoning to figure out the precondition of line 2 and line 4. But I guess it's sometimes it's better to follow one branch all the way through, and then we start on the other branch and follow that all the way through. Different brains work differently.
Yeah, now I see.
Mine sometimes just doesn't work.
That's just awesome.
That explains everything.
But we're not done yet. Okay, we're not done yet. We have post 2 and we have post 4. But what about post 5? Okay, let's think about it. Post 5 is, what do we know or what can we confirm after the entire conditional statement is done? What we have confirmed at this point is what do we know right after line 2 and what do we know right after line 4. But what about right after line 5? That has to do with the structure of the code. Is post 2 or post 4. So in terms of actually coming up with the expression, it's just a matter of copying and pasting. So you just copy what it post 2 and paste it here. Copy whatever is in post 4 and paste it here.
Execute syntax error.
And then we're done. But does it make sense? By the time we get out of the conditional statement, does it make sense that we know that x is greater than or equal to 20 and z equals 5, or x is less than 20 and z equals 7? It makes perfect sense. Because when you look at the conditional statement itself, that's exactly the outcome that we should expect from a conditional statement like this. All right. Any questions? questions? All right. Well, let's go ahead and do another. I will have you guys work on another example, but this time it's a little bit different. So we'll change this one to z gets x z plus 1. And then instead of giving you pre-1, I'll give you post-5. And I'll say post-5 is, guess what? Z equals 7. I want you to work your way back and tell me what is pre-1. Now, okay, now this one is a little bit, it is walking backwards, okay? It's walking backwards, and you have to apply the same type of reasoning. I'm not going to make this really formal or rigid, but I do want to explain how to make this work, okay? All right. Now, this is kind of interesting because both branches are actually applicable. You can take either branch backwards, but it will give you a different precondition. Is it making any sense? I don't know. Okay. Now, what is post 5? Post 5, technically speaking, post 5, because of the structure of the code, is post 4 or post 2, right? We know this part because of the structure of the code. Now, this is basically saying, if I know that post 4 or post 2 is z equals 7, can I discount one or the other one?
No.
Yes.
I cannot. I cannot, really, I cannot. Because it is possible that post 4 is z equals 7, and post 2 is also z equals 7. Okay? This implies that post 4 is z equals 7, or post 2 is z equals 7. I cannot discount one or the other at this point. Okay? Let's take one branch at a time. Let's look at line 4. If I tell you that after line 4, z has a value of 7, what can I say about z before line 4? Absolutely nothing, right? Z can be anything, because line 4 overwrites the value of z without referring back to itself. There's no inverse function to apply here. So there's no way for me to reverse back to the value of z before line 4. So that means, because of this reasoning, we can now say that pre-4 is just, well, let's see here. Is it just true because we don't know anything? Or is there something we actually can state as pre-4 because of the structure of the code?
X has to be less than 20 for
Yep.
4 times 1.
So at this point, we have to say that we also know the condition has to be false, which means x has to be less than 20. Is that making any sense? The true comes from the fact that it's not possible to reverse and find out what z was before line 4. But the other part comes from the fact that this is the first line of the else branch, and at that point we know for sure that the condition of the conditional statement has to be false. And we can now simplify this to just x is less than 20. This is the boring branch. The other branch is more fun. The other branch is more fun because we are saying post 2 is z equals 7. And that part comes from this part here. Okay? In order for post 5 to be z equals 7, this can contribute to that. Without using without using the sub operator and all that substitution operation, can you just kind of use your reasoning and tell me if post 2 is z equals 7, what is pre 2? What do you think the value of z is?
6.
Has to be 6, right? Because line 2 increments the value of z. If we know post increment it is 7, pre increment has to be 6. But there's one more thing we also know, because line 2 is the beginning of the then branch. So at that time, before we had a chance to change the condition of the conditional statement in here, in this part, has to be true. Exactly. So x is greater than or equal to 20. So now we have pre-4 being this, and then we have pre-2 being this. What is pre-1? Not quite. Okay. Now remember, we are walking backwards. In other words, I'm standing at the beginning of the branch, and I'm drunk. I cannot remember how I got there, but I know that I have to get back to this point from one branch or the other. So what can I do about this? Because I can come back from either side. So if I can come back from either side, I can only state a simple or. Then we can just copy and paste. Pre-2 is this mess here. And then pre-4 is simpler. It's simpler simply because there's no way for me to figure out the value of z before that point. Okay. Why is this helpful? Tech, why do you torment me like this? Yes?
Debugging.
For debugging, exactly. Because what happens when you observe your program is not working correctly? You stop the program, you check the variables, and you say, at this point, they're not supposed to have these values. What do? You
work backwards.
You walk backwards. Or you try your best to walk backwards. Sometimes at some point you cannot walk anymore. But in this case, if you know after line 5, for some reason, z has the wrong value, and you want to see how I could have gotten here to begin with, you walk backwards, and then you can say, if I know for sure that immediately after line 5, z has a value of 7, I know for sure that this condition has to be true before line 1. Now that is really useful, because now it tells you something about the value of x and also the value of z in a certain branch before line 1. And if you continue with this approach and continue to walk backwards a little more, it may be able to lead you to the source of the problem. But you can see how this can be a little bit tedious when you have millions of lines of code. But the logic doesn't change. Okay? The way you approach a problem, the way you approach a defect in programming is still the same. You stop, and then you basically take a snapshot of the values of the variables at that point, and then you try your best to go backwards and try to locate the source of the problem. Now, what do you do in this case? Because in this case we have an OR, which means it is possible that x is less than 20, and I know nothing about z. That's one possibility to get me to the post condition that I state here. Or it is also possible that z equals 6 and x is greater than or equal to 20. So
It's much more restrictive than the other one.
one is more restrictive than the other one, because the first one, the one that I'm pointing out right now, is more restrictive. So, but you have to follow each one, continue to go backwards, assuming that this can be true or this can be true. So in other words, the precondition will get more and more complicated as you continue to walk backwards in your code. Are there any questions about this part, walking backwards instead of walking forward? Do you feel that you have a bigger toothbrush now? Remember the toothbrush, as your first job as a developer? This gives you a bigger brush. It's not a toothbrush anymore, it's a toilet brush. All right, we are running out of time. I will give you guys a new homework assignment. I will assign that online and send you guys an email about the new homework assignment. And I will see you next Tuesday. Have a nice weekend. And I'll save it and upload the files too. You can do that.
Did you do both?
Did you do roll today?
No, I forgot.
Okay. Class?
Yeah.
When are we going to have an exam? Next week or next week?
I always give the class a practice exam, and then 1 week after the practice is the actual exam. So we're at least 1 week away. I want to spend next Tuesday to continue to give you guys more examples. And then on Thursday, on next Thursday, I'll give you a practice test. So the week after next Thursday, 2 weeks from today, we'll have our first exam.
Thank you.
Still no word from the dean about the petition.
Oh, I forgot about that. Yes, he said yes. So go ahead and fill in the petition form. He will add everybody in the class.
How do I do this?
You go to admission and records and pick up a petition to add. They will give you 2 slips of paper. One is the petition form, and then the other one is the regular add slip. You bring both back to me. Fill in your part first, and then bring it back to me. I will state the reason why you should be added to the class, and then the dean will agree to add everyone who's on or not even on the wait list to the class. So you're good. You just need the paperwork to do it. Yep. Sorry?
Was he trying to add Joseph's different?
No, to this class. I need to send a message to everyone, who's here. I did not pass the roll sheet today, so you're good.
It's like if I use, I like the Windows, all the
Yep,
time.
go ahead.
I have a question about Rasa.